Hello everyone, good evening. Welcome to the C++ session organized by Gurukul engineers. I hope you had a good day today. We'll be beginning with the session for today, and since I can see only 7 participants have joined the session till now, I request you all that please, those who are having friends in the session, ask them to join the same. And before beginning the session, I would request you all that please keep your audios and videos in the off mode and ask questions using the chat window. Do not use the annotate option because it is not for you all, it's for the trainers. And again, if you have any kind of doubt, please put your doubts on the this chat window. Okay. So let me begin with the today's session. And today's session is completely based on pointers. So let me just open it up. Okay. So yes, now this is very last topic of your C programming. Hopefully we'll be finishing up the C programming today, and tomorrow we'll be starting with the C++ concepts. And one thing I would like to tell you is that till now what we have done in C is also being implemented in C++. So if I talk about operators, type of operators, variables, constants, conditions, literals, decision-making statements, loops, if loop, for loop, etc. Everything is same in C++. So for all these topics, I'll not be repeating it again. The same is being done in C++ also. Right? And tomorrow we'll be beginning with the classes itself. So this is the very last topic of your today's C programming. That is your pointers. Let me begin with the C programming of pointers. Now today we'll be talking about pointer definitions, declarations, how do we use operators with pointers, arithmetic types of pointers, relationships, right? Okay. Now, first of all, let me talk about what is a variable. We know that variable is a named memory location, right? And variable provides direct access to its memory location. Now, what is a variable? We know that there was no uh, uh, like if I talk about a variable is used to assign a particular value to a particular memory location, right? Now let's suppose I think all know what is a variable and how do we store value into variable and how do we access particular value from a variable, right? Now a variable has a name, an address, a type, and a value. You know that if I talk about this variable, it's like int a 20, right? Now what is this? It's a value. 20 is the value. A is the name of the variable. This is the type, or I can say data type, right? Now I know that in the memory, variable A is stored at particular location. Variable A is stored at particular location, and the address of this variable A or address of this memory location could be 2402, let's suppose. Okay, so every variable has 4 things. What is 4 things? One is the data type, second is the name, that is A, third is the value, and fourth is the memory location, the address of the memory location where this variable is stored, right? Now, the name identifies a variable to the programmer. How can a programmer comes to know about a variable? By its name. But to the compiler, the address specifies where in memory the variable is located. Now, a programmer does not have anything to do with the address. Who is responsible for using the address or for whom the address means is the compiler. Because compiler recognizes a variable by the address. but the programmer recognizes a variable with the name. Whenever a person gives call A, or I can say A enter, the command is run by the compiler. Compiler goes and fetch the go to particular memory location, that is 2402, and from 2402 it brings up the value 20 and return it to the programmer. So for the compiler, address means everything, right? Now is pointers. Now, what are pointers? Pointers are actually the special variables that are used to hold the address of another variable. Uh, this is what we are going to study in detail, what is a pointer and how they are useful, right? But let me tell you that pointers are special variables that are used to hold the address of another variable. So for example, if I take a rough example, I'm having a is equals to 20. That is this. Right? It is value is 20. Let's suppose it is stored at address 2402. Right? Now, if a programmer wants to return this 2402 address on the output, so for that I can say I can take a variable p, who is going to point at variable address of variable a. So this will be my, so p will be storing what? P will be indirectly storing 2402. Right. So a, the value of a is 20. It is stored at memory location 2402. Now b is responsible for storing the address of a, that is 2402. Now pointers variable syntax, we normally say type, the type of the pointer, and there's an asterisk symbol, which normally in programming language means pointing, and this is the name of the variable, right? So you start by specifying the type of the data stored in the location identified by the pointer. So which type of data, let's suppose, as I told you just now, as we have taken a variable a is equals to 20 and a is of the type integer. So the variable b, who is storing the address of a, will also be of data type integer, because it is storing the address of that variable whose data type is integer, right? So you start by specifying the type of data stored in the location identified by the pointer. The asterisk tells the compiler that you are creating a pointer variable. Finally, you give the name of the variable. This is actually a syntax definition or explanation about the syntax, right? Now, how do we declare and initialize the pointer? So the declaration says data type, asterisk symbol, pointer variable name. So it is inst asterisk p. We normally call it as star p, inst star p. So syntax for initializing of a pointer is p is equals to like pointer variable name, that is p, is equals to, this is ampersand symbol, right? It's available on the keyboard on the key that is containing 7 as a numeric, right? So it's an ampersand symbol and the variable name. Now what does this mean? This means that my variable p is storing the address of who? Variable a. So a means ampersand, a also represents the address. So address of a will be stored in p. Okay, I hope it's clear to all. Till this I'm clear to all. Okay, am I clear to all? Yes. So how do we declare a pointer? It's like in star pointer and char star pointer. If anybody's mic is on, please keep it off. I request you again. Shri Hari, I can see your mic is on. Okay. Next is a pointer can point to value of its own data type only. Right? A pointer can point to value of its own data type only. That is, if a pointer is of integer type, it can store the address of integer variable only. See, again, if I'm creating a pointer of character, it cannot store the value of an integer variable. right? It cannot store a value of integer variable. A pointer who has to store the address of integer variable should be of integer type pointer. Anybody who can find the error over here? Shri Hari, are you am I audible to you? So what do you think is the output error in this? No problem, Aniket. I'll request you all that please from your end keep mute all in your session if you could. Okay, anybody who can say that, tell me what is. No problem, Aniket. Okay, anybody who can tell me what is the error in this? No, no, not at all. Please follow the concept which I have just told you. If you can see this concept, if you remember this concept, a pointer who is storing in the address of integer variable should be an integer pointer, and the pointer who is storing the address of character variable should be a character pointer. So moving with this, let's see the program again. What do you think is the error in this program? Keeping this thing in your mind. Yes, very good, Aniket. See, here we are having a is equals to 10 as an integer variable, right? And in this case, pointer is storing the address of, and we are taking integer pointer, correct? In this case, pointer is storing, pointer is storing the address of A. So this is correct, no problem in this. But in case of B is a float data type. So how come address of float variable could be stored in the integer pointer? So here, there's an error. This is the error in your program. B is a float type, but the pointer is a integer type. So this is the error in the program. Right? I hope it's clear to all, Sneha. Sarvesh? Okay. Next is pointer's address. So this is the address pointer and this is the indirection operator. Normally we call it as address operator and this is called the indirection operator, which is directing to a particular value. Address operator, once we declare a pointer variable, we must point it to something. We can do this by assigning to the pointer the address of variable you want to point as in the following address. That means my pointer variable is storing, or I can say pointing to the address of num variable. Right? This place the address where num is stored in the into the variable pointer. If num is stored in memory 2126 address, then the variable ptr has the value 21260. I hope it's clear. Pointer num is stored at which location? 21260 in the memory, and ptr will be having what kind of value? 21260. right? Now address and pointer, like this is how it works. This is contents one, like variable one, it is stored at address one. Yes, Aniket, a pointer variable will hold the address always, right? So this is your memory always look like this: address one, address two, address three, and so on. So this is, if I'm having 16 contents from 1 to 16, every content or every variable will be having different address, and they're always stored in the contiguous memory. Contiguous means in a regular form, right? So this is assume pointer is a pointer variable, x is an integer variable, right? So x is 10, so it will get into this variable x mem, and so if I say pointer is equals to ampersand x, so ampersand x, this pointer is going to point to this value x. Right? Now pointer, with the help of particular pointer, we can access the value of x. Is it clear to all? Can you, are you having any doubt in this topic, like in this slide? Okay. So I'm having a program. This program says int a is equals to 5, int b is equals to 6. So a is having value 5, b is having 6, and my a is stored at which memory location? 1001. B is stored at which memory location? 1003. And I'm saying int pointer c. So I'm creating a new variable c, which points to a via this. C is equals to ampersand a, right? Now C is also a variable. It is stored, its own address is 1005, but it is storing the address of who? A. So A's address is 1001. So the value of C will be 1001. I hope it's clear now. See, pointers is a very important topic in your programming. They are very useful in doing multiple tasks. So reference ampersand retrieves the memory address of variable, same. Now what do you mean by dereference? Reference is like C is pointing to A. So C is referring who? A. Now there is an other concept called as dereferences. Now in case of dereferences, we access the variable content the pointer points to. Right? How? I'm saying int A is equals to 6. So this is my variable. The value of A is 6. And then I say pointer C is equals to ampersand A. That means C is pointing to address of 6. Then I say pointer C is equals to 7, right? Pointer C is equals to 7. Now, this is I'm assigning particular value to whom? C. So what will happen? See, we know that C is pointing to A. So what it is going to do? C is again going to change the value of A from 6 to 7. This is called as dereference. Am I clear to all? Yes, am I clear to all? Okay. See, I'm having a variable A, which is equals to 6. Now, let's suppose A is stored at 1, 2, 2, 4, right? So, if I say pointer C is equals to ampersand A, so what will be C? C will become 1, 2, 2, 4, because it stores the address. We know it's clear to us. Then I say pointer C, this value. Pointer C is equals to 7. Now what does this mean? This means that pointer C is pointing to any variable, whosoever variable C is pointing. That means C is pointing to this A. What we have to do, we have to replace that variable with value 7. So what will happen in this case? As soon as I write this command, my compiler will check that my pointer C is pointing to whom? That is A. And it will go to that particular address. That means it will go to 1224, right? And change the value at there from 6 to 7. That means it will assign a new value to a variable whom C is pointing, right? And that new value will be 7. Am I clear to you all now? Okay. So let's move to the next. This is my code. It's a basic simple code. It tells you that what use of pointer operators are. So we are having A, and I'm saying pointer APTR. It's a name. You can write any name, okay? And I say A is equals to 7, and APTR is pointing to ampersand A. That is APTR is storing the value of 7. APTR is storing the value of A, right? Address of A, not the value of A, address of A. So I say printf, the address of A is whatsoever the address will be, it will be printed, right? And the value of APTR is this, right? Any doubt in this? Right? See, what is this? This is actually address of A, right? And APTR is actually APTR. APTR is showing the contents of A. See, we can if I want to fetch the address of a particular variable, I can write like this. So what is the address of A? I can return the address of A using ampersand A, right? Clear. But if I say if I'm using this statement, what is APTR? APTR is equals to ampersand A. Now we know that address of A is 1223 and APTR is equals to ampersand of A. So APTR should also be equals to 1223, right? APTR also should be equals to 123. So this is same. The value in this both the cases should be same. Address will also be 1223. Let's assume that 1223, and APTR will also be 1223. Right. Then is the value of A is percentage D. Like the value of A will be 7, and the value of APTR, pointing APTR will also be the value which is getting from A. So let's see the output for this. So let's have an output for this. We are having an output for this. Now the address of A is 0012212FF7C. This is the memory location where the A is stored. And the value of APTR is also 00122. It's same, right? Next is the value of A is 7 and the value of pointer APTR is 7. One thing I want to clear you here. See, I've said you that A is equals to 7, right? And then I say int pointer APTR, right? Now let's take location. So this is A, it is 7. Assume that the memory location where A is stored is 1, 2, 2, 4. Okay. Now if I say printf APTR, right? If I write APTR, now what will be the output? In this case, the output will be 1224. That is the address of a variable, right? But if I write here printf pointer APTR. In this case, what will be the value? The value will be 7. That means the actual value which is stored in A, or the actual value whom this APTR is pointing, that is 7. Any doubt in this? Any doubt in this? No. And one thing you need to keep in mind, that when we are printing address, the format specifier will be percentage, right? And whenever we are printing the value of the variable whose APTR is pointing, in that case the format specifier will be according to the data type of the variable. If A is integer, format specifier will be percentage %t. If A is float, in that case format specifier will be percentage %f. Now any doubt to anybody? Okay, so this is what is done here. When we are printing the address of A, or we are printing the contents of APTR, in that case the value will be 001227777F, all that. But if we are writing the pointer APTC, that is what I have told you, pointer APTC, in that case the value will be A. Okay, and this is now showing that pointer and ampersand are complements of each other. Pointers and ampersand are complements of each other. How? See, if I write you know that pointer APTR is equals to, if I write here, see, pointer APTR is equals to 7, yes or no? We just told you pointer APTR is equals to 7, right? But if I write in front of APTR, if I write here address, and if I write here address of 7, is it same thing? If I write here ampersand pointer APTR, and if I apply ampersand in front of pointer APTR, what it will return? It will return me the ampersand of 7. So ampersand of 7 is the address where 7 is stored. That in that case, what it will return you? 0012FF7C. I repeat here. You know that pointer APTR is equals to 7, right? And if I apply ampersand pointer APTR, that is equal same as ampersand of 7. So ampersand of 7 is what? So ampersand of 7 is the variable, that is A. Ampersand of A is address, that is 01123, where it is stored. Is it clear to all? So this is how you can also change your program, and this also means the same. If you change the position, this also means the same. It will always return this. Like, see, if your variable contains this ampersand symbol, it will always return you the address to whom it is pointing. This is what you need to keep in mind. Let's move to the next. So this is like you can do it on your own. Write a program to store the address of a variable and print the value and address of a variable through pointer. So if I'm using variable A, that is 5, and let's suppose A is stored at location 3779. So what I want to do, I want to print the value of 5, and I want to print this 3779 with the help of pointer. So let's suppose I take here A, right? And then I say int pointer is equals to suppose I am taking a pointer, right? Then I say um, pointer is equals to, sorry, where should come ampersand A, right? And then I say printf percentage p pointer. This is for printing the address. And then I say printf percentage d. This is for printing the value of the variable whose PTR is pointing. So it will return you 779 and this will return you 5. Okay. This is how you need to make a program for us. So pointer arithmetic, we can also perform some arithmetic operations using pointer. We can perform the sum of a pointer and an integer, right? We can add an integer to a pointer. We can perform the difference of an integer with a pointer. We can also perform the comparison, like difference of two pointers. We can also increment or decrement the value of pointers. We can assign operator used in pointers. Now let's see how we can do all this. This is an example, basic example for my addition of two values, right? So I say int a is equals to 25, a is equals to 25, and then I say b is equals to 78. I am taking two pointers int x and y. X is equals to ampersand a. So x is going to store the address of a. Let's suppose it is 2443. So x will be 2443, right? And b, y is going to store the address of b, or I can say, in the other words, I say that x is pointing to a and y is pointing to b, right? If I write here sum is equals to pointing x. Now what is this? Anybody who can tell me? What is the value returned by pointer x? Is it 2443 or 25? Anybody who can tell me? What is the value returned by pointer x? Yes, it is 25. What is the value returned by pointer? Y? It will be 78. So what I have to do? I have to do sum is equals to pointer x plus pointer y. So what will be the output here? It's 103. So then I print the sum. It is 103. I hope it's clear to all. Now in this case, anybody who can tell me what will be the output? X is a value in variable, and then I'm creating a pointer. I say x is equals to 10. So the value of x will be 10. If I write here pointer is equals to ampersand y, that means pointer is pointing to whom? Pointer is pointing to x. Then I say x is equals to x plus 10. That is, it becomes 20. Okay, just a second, please. Let's suppose I'm having a variable x, which is at having the value 10. It is stored at 2449 memory location, right? Now a pointer is pointing to x. Then I say the x is equals to x plus 10. So this becomes 20. That is 10 plus 10 is 20. Now then I say printf percentage d pointer ptr. So what will be the value of printed at this location? Anybody who can tell me? Yes, I think this session is for everyone. I need the answers from everyone. Ali, what do you think? Anvita? Ahmed? So what will be the output returned here? Mukesh, do you think it's correct address? See, when there is asterisk, it always return the value of that variable. It will be returning you 20, not the address. But if I don't write this pointer here, if I remove this pointer, in that case, it will return you. And in this case, if I return the P, right at P, in that case, it will return you 2449. Okay. Assignment and pointers, how do we assign the values to pointers? Like this is one way. I'm having two values, pointer P1 is equal and pointer P2. I say P2 is equals to P1. So what it does is assign one pointer to the another pointer. It makes point P2 point to where P1 is pointing. So if I'm having P1 and there's a variable X which is having value 10, right? If P1 is pointing to X, right? And then I say P2 is equals to P1. In that case, what will happen? P2 will also start pointing to variable X whom P1 is pointing. Because I'm making P1 as equal to P2, so P2 will also do what P1 is doing, right? Again, what is the difference between this value and this value? Can you understand this? If I write here asterisk, in this case, what will happen? In this case, what will happen? P2 will be equals to 10. Yes. In this case, P1 will start the address of X, that is, let's suppose 2403. Right. In the first case, since P1 is pointing to X, P2 will also start pointing to X, and the P2 will be having value 2403. This is happening in first case. But in second case, P1 is, we have written asterisk P1. P1 is having value 10. If I write here P2, P1 asterisk P1 is equals to asterisk P2. In this case, P2 will also become 10. The value of that variable will be assigned to that particular second variable pointer. Hope it's clear to all. Mukesh, Ali? This is the diagrammatic representation of the same which we have done right now. So P1 was pointing to 8, P2 was pointing to 9. If I write P1 is equals to P2, P1, so what is happening? The address of P2 is assigned to P1. P1 will also start pointing to P2, right? And if I write here, P1 is pointing to 8, P2 is pointing to 9, right? But if I write pointer P1 is equals to pointer P2, the value of P2 will be assigned to pointer P1. So 9 will be saved in P1 also. Earlier it was 8, but now it is 9 because value of P2 is assigned to P1. What do you think is the output of this program? Yes, can I get your responses, please? What do you think is the output of this program? A is 10, B is 20. Pointer P1 is pointing to A, pointer P2 is pointing to B. Then I say printf pointer P1, pointer P2. In this case, the value will be 10 and 20. Then I say pointer 1 is equals to pointer 2. So 1 is also going to point to whom? 1 is going to point to whom? 1 is also going to point to P2. So PTR will be also pointing to B, right? Then I say B is equals to B plus 1. So the value of B becomes here, initially it was 20, and then I make it as 21, right? Then printf asterisk pointer P1 and pointer P2. So in this case, the output will be 21 and 21, correct? And printf PTR, PTR1, PTR2. So let's suppose the B is stored at memory location 2402, right? So this will be what? 2402, and PTR will also be 2402. I hope it's clear to all. Let's move to next. Right, now next is this, you can do yourself. Write a program to compare two pointers contents and find which one is greater. Like contents means the values, like A and B, whom pointer P1 and P2 is pointing. Now this is the increment and decrement operation, which we can do only using the pointers. So initially I'm having value data type I is equals to 2. Initial address of I is 4046. If I write here plus plus, right? Now plus plus means incrementing the value of I, that is it becomes 3. Similarly, as soon as I increment the value of I, my number of bytes will also be increased. So it will be 4048. But if I write here minus minus, that means from 2 I am making it as 1. Right? Here comes 3 and here comes 1. So as soon as I decrement it, the address will also be decremented by 1. So it becomes a 4044. Right? Char C x C is equals to x. So initial address is 4053. In case of character, it data type like your data type character takes only 1 byte. So plus plus will increment the address by 1 and minus minus will decrement the address by 1. Float 2.2, you know that float takes how many bytes? 4. 4050 was initial address, plus will add 4 and minus minus will decrement 4. And the last one is your long L. Long also takes how many bytes? 4 bytes. Long is your int. Talking about long int here, right? So 4060 is the initial address, plus will increment by 4 and minus minus will decrement by 4. This is like operations which you can perform on the pointer. This is like you need to find out the output. Anybody who can tell me what will be the output in this case? I'm having an array which is of size 5. The values of arrays are 20, 20, 30, 40, 50, right? And then I say PTR1. So PTR is pointing to this array. PTR1 is equals to ampersand A. Now in this case, PTR1 is saving the address of which variable, that is A. Let's suppose you know that array ten, 20, 30, 40 and 50, right? Let's suppose the address of this is 102 5. So anybody who can tell me what will be the address of this? Next address will be, what will be the address of 20? It will be 102. Yes, everybody. What will be the address of 22nd element? 1027. 1029, 1031, and 1033. Right? So if PTR is pointing to A0, that means it is pointing to this. And then I say printf PTR. So what will be the output in this case? 1025. Right? And then I say PTR plus 1 plus 1. So what it will do? It will give you 102. 1025 will be incremented by how many bytes? That is 2 bytes, because it is of type integer. So this becomes 1027, and printf, what will be PTR? 1027. Okay, I hope it's clear to you. It's just similar link to the previous thing which we have topic which we have done. Incrementing address. Now, similarly, I can subtract 2 pointers also. Now, this is how we do it. PTR is equals to V2 and PTR is equals to V0. If I write X is equals to PTR2 minus PTR, assign to X the number of array elements from PTR2 to PTR. In this case, see, in this case, what do you think will be the output? Yes, in this case, what do you think will be the output? See, in this case, we are not subtracting the addresses. We are not subtracting the values stored at 2 and 0 index. But what we are doing is, we are subtracting the number of elements from first array to the second array. So, if V2 is having, this is V2, that means this is index second and this is index 0. So what do you think, how many elements will be there from 2 to 0? If I write 2 minus 0, elements will be 2. Okay. So it's written over here, assign to X the number of array elements from VPTR to VPTR2. In this case, it is 2. Now, what is the relationship between arrays and pointers? Second, please. So what is the relationship between arrays and pointers? So array name is starting address of an array, right? So let's suppose I'm having an array vals, which is having how many values? 3 values, right? The starting address of vals is 0x4a0. So this is the starting address, that is 0x4a00, right? Now printf vals, so what it will print you? It will print you the starting address. It will print you the starting address, like we did in the form of normal integer variable, right? The address of first index. But if I write printf vals 4, now in this case it will give you the value at vals 4, 0. The values at this index, right? And this is like, it will display you 4. Any doubt in this? Like, this is similar to the one which we have done in the previous slides. If we write PTR it returns you the address. And if we write pointer PTR, it returns you the value of the variable it is pointing. It's the same. Okay. So friends, as we have done that, let's suppose x is a variable, and we write PTR is equals to ampersand x. That means my pointer is pointing to x. If I write here pointer, it will give me the address, that is 0. Let's suppose 2428. This is the address. PTR will give me address, right? And pointer PTR, asterisk PTR will give me value, right? Similarly, in case of arrays, if I write here printf vals, it will give me the address, that is 064A double. Right? But if I write vals 0, like index of the array, in that case it will give me the value at that index, that is 4. This is what I wanted to tell you. How pointers and arrays work together. Am I clear to all now? Am I clear to all now? Yes. So array name can be used as a pointer constant. Yes, Aniket will be doing this the same thing by this also. Array name can also be used as a pointer constant. So how? If I write here, just a second. Okay. Okay, Aniket, what I was telling you is that let's suppose I'm having values. This is the array which contains 4, 7, 11. This is my vals, right? This is val 0, and this is val 2, right? The starting address of val is 0x4a0. This is the starting address. That means the address of val 0 is 0x4a00. Right. Now, if I write printf val, simple, it will print me what? It will print me the address. That is this 0x4a00. But if I write val 0, in that case, it will print me the value at index 0. That is the 4. This is simple if I want to print the address of arrays without using pointers. Am I clear now? We are not using pointers here. We are just printing the value of the array and the address of array. How we can normally print the address and the value of array. So writing simple vals, it will give me the starting address, and vals 0, that is the index, will give you the address, or sorry, value of that particular element index. Next is the relationship between arrays and pointers. Now, array name can be used as a pointer constant. How? Like, let's suppose I'm having a value array 4, 7, 11, right? If I write printf asterisk vals, it will give me what? What do you think? What do you think it will give me? What? Pointer vals. Everybody, can I get your answers, please? It will give me all values, that is 4, 7, and 11, right? But if I write pointer can also be used as an array name. If I'm having a pointer, asterisk val pointer is equals to vals, right? So if I write val pointer 1, in this case, what will be the value? Yes, correct. Very good. Very good, Aniket. No, Aniket, it will not be 4. Mukesh, it will be 7. Because, see, we are writing val pointer 1. This is index 0. This is 7, 1 and 2. Good, very good. So if I'm having like this, now let's see what will be the output of this case. A 10, 10, 20, 30, 40. So this is the all the values in the array, right? If I write printf A, what will be the value? Address, correct. It will give you address. If I write here asterisk A, it will give you okay. Let's keep it as like this. Printf A plus 1. Okay, what will be this value? Ampersand A0. Ampersand A0. Aniket, no. But I told you that wherever I use ampersand, it will give me the address. So it will give you the address of 10. Right. What is A0? It will give you. It will give you A0 will give you 10. Correct. Ampersand of A1 will give you address of 20. Very good. And A1 will give you 20. Right. Similarly, see here. A will give you address of first element. First element is 10. That is address of 10. Pointer A will give you value of first element. That is 10. Right. A plus 1. It will give you the address of second element. That is 20. Right. And pointer A plus 1 will give you the value of second element, that is 20. Did you understood this all? So see, this is the relation. If I write printf percentage %PA and if I write printf ampersand A0, it is same. They both are same. Okay? And if I write printf pointer A and if I write printf A0, they both are same. Right? And if I write printf A plus 1 or if I write printf ampersand A plus 1, they both are same. They are going to return you the value address of second variable. And if I write printf pointer A plus 1 or printf A1, it will give you 20 as the output and they are same. So there are two ways for doing the same operation. Am I clear to all? See, I know that in the one go it will not be able to understand you all, but as soon as you practice in your program, you will be clear about all this. Is it clear to all? Yes, Sabesh, Mukesh, Ali, where are you right now? Okay, that's good. Let's move to the next. So this is like same thing, pointing and pointing the values to all. Same which we have done is right now. P1, 10, pointer P2 is equal to P1 and all that. You can practice also. This is like practice question. Comment on the following pointer declaration int pointer P and P. So what is it is doing? Any answers from your side? What will be the answer of this question? There is a declaration of this int pointer P, int pointer and P. There are two variables which I have taken. So what do you think is the answer according to all this syntax? Yes, pointer is a pointer to integer and P is not a pointer. Correct. So this is like a program. It will return you every this output. Like it's a program and you have to find out that what will be the output accordingly. I'll give you the slides and you can just see once into it and get the outputs and solve this outputs question. What is an indirection operator among the following? What do you think? I think I've told you the answer also. Indirection operator. Yes. No. 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 Indirection operator. See, pointer is an indirection operator. The A option is address operator. I just told you in the starting, pointer is an indirection operator. Absent is an address operator. Again, there's a question and you have to find out the output for the same. You can see into it and do it. Indirection means it is pointing to something. Aniket, like I say, just a second. This is again an so question. You can solve it out. Now, see, now comes the types of pointers. We have 4 types of pointers with us: void pointer, wild pointer, null pointer, and dangling pointer. Now, what are they? Let's see into it. Now, if I talk about void pointer, a void pointer is a pointer that can hold the address of. It can hold the address of variables of different data types at different times, also called as generic pointer. Remember, if a question comes to you that what is a generic pointer, you should always remember that generic pointer is same as the void pointer. Okay. Now, what does this mean? The syntax for declaring a void pointer is void pointing pointer name. Here, the keyword void represents that pointer can point to any value of any data type. Like suppose, as I've told you, if I say int ptr, pointer ptr, now ptr can point to a variable which is of which data type? It should be of integer a, right? But if I create void pointer, void ptr, now it can point to integer also. It can point to character also. It can point to float also. Now void means this, the data type of the pointer is not defined. It could be, it is decided at the runtime. Now what is runtime? Dynamically, the pointer will be pointing to the variable. The data type of that variable will be assigned to the pointer itself. So void means dynamic data type, or I can say no data type. The value of the data type will be decided at the time of runtime. So that is why I call it as dynamic. Right. But before accessing the value through generic pointers, by dereferencing it, it must be properly typecasted. Like that means if I am using the dereferencing, in that case it should be a typecast. Properly typecasting should be done. To print values stored in pointer variable, like this is how we do the typecasting. Right. I'm saying here name of the pointer, and let's suppose it is pointing to x is 7. I say void ptr. In that case, if I return ptr, it will give me, just a second please. So what is the value of pointer PTR? It will be 7, right? But if I want to assign a new value, I say that in this case, if I assign a new value 8, let's suppose, in that case I will not write like this. What I will do, it will give me error. This will give me error because the pointer is of which data type? Void. So while assigning a new value, I have to do the typecasting. So how I can do? I'll say int and ptr. This is called as typecasting equals. I hope it's clear to all. Any doubt on this? What I've just explained right now? Yes. Good. Okay, Sarvesh. Okay. Now let's move to the next. Limitations of void pointer. Void pointers cannot be directly dereferences. They need to be properly typecasted. Pointer arithmetic cannot be performed on void pointers. Like I cannot perform any addition operation on void pointers because I do not know the data type of the value this pointer is pointing. So if I know the data type, I can do it. But this is again a lengthy process, which is like making the program more complex. So we avoid performing any arithmetic operation on void pointers, right? Now this is the program of void pointing. This I told you, as I told you. A is equals to 10, cache C is equals to R, void pointer, PTR, right? Now PTR is pointing to whom? It is pointing to 10. Now if I want to return the address or the value returned by this pointer, I have to properly write pointer int pointer ptr. This will give me what value? It will give me 10, right? And if I write this pointer char pointer 10, it will give me what value? It will give me r. Okay. So what is wild pointer? Now pointer which are not initialized during the definition. Now they are called as wild pointer, and they always hold some junk value. Okay. Example of wild pointer is int pointer ptr. Every pointer when it is not initialized is defined as a wild pointer. A pointer as pointer get initialized start pointing. Initializing means it start pointing to a variable. It is not a wild pointer. Like let's suppose now here I am declaring a pointer. This is my wild pointer. Why it is a wild pointer? Because yet now it is not pointing to any variable. But when I say ptr is equals to ampersand a, in this case, it is the wild pointer has been converted into my void pointer. So it is no more a wild pointer. Why? Because it has started pointing to a particular variable. But as just when we declare it or define it, we call it as a wild pointer. Because it is not storing any address, it is just storing the garbage value. So let's move to the next. Null pointer. A null pointer is generally used to signify that a pointer does not point to any object. Null pointer is a type of pointer of any data type and generally takes a value as 0. This is however not mandatory. This denotes the null pointer does not point to any valid memory address. So example of null pointer is this. Why? Int asterisk ptr. It's a wild pointer, right? When I say ptr is equals to 0, it becomes my null pointer. Why? Because we have assigned any value to null value, that is 0 value to my pointer, right? And it is called as null pointer. Here we have not assigned any value, so it is my wild pointer. Okay. The above statement denotes PTR as an integer pointer type that does not point to valid memory address. This shows that PTR has null pointer value. Difference between null pointer and void pointer. Void pointer is a special type of pointer of void and denotes that it can point to any data type. See, in case of void pointer, we don't give any value to it. We don't assign any value to it, right? And in that case, we assume that it may point to any particular address in future. But in case of null pointer, we assign 0 to it and we are sure that it will not be pointing to any variable. So it will be having a 0 value or the null value. This is the difference. Is it clear to all? Next is dangling pointer. Now what is dangling pointer? Dangling pointer is a pointer which is pointing to any invalid location. Right. Now what does this mean? It means that dangling pointer arrives when an object is deleted or deallocated without modifying the value of the pointer so that the pointer still points to the memory location of the deallocated memory. Now let's take an example for this. This is the example of dangling pointer. Now what is dangling pointer? See, this is an object. This is an object, right? There was an object, there used to be an object X, but after some time I deleted this X. So it is no more in the memory, right? But the pointer PTR who was pointing to X earlier is still in the memory. It is still in the memory. It is not deleted. This variable is not deleted, but X is deleted. So this variable PTR is going to store the address of X. Though X is not in the memory, but since it is pointing to X, it will be storing the address where X was created earlier or before deletion. This is called as dangling pointer. Though my PTR is pointing to X, but it is a invalid operation. Why? Because X is already deleted. So on the whole, I can say that dangling pointer is a pointer which is pointing to a memory location which does not contain the variable or the variable is deleted. So it is pointing to a garbage address, right? So pointing to a garbage address. See, dangling pointer is always asked in the interview or the MCQ question. It is very important. Is it clear? Dangling pointer is clear? Difference between dangling pointer and null pointer. Dangling pointer are those which points to invalid location, right? But null pointer, in this case, in case of dangling pointer, the object is deleted. But in case of null pointer, no, null pointer is that pointer which is not been allocated any address. That is why it is null. But in case of dangling pointer, initially the object was allocated to a pointer, dangling pointer, but later on that object was deleted. So my dangling pointer keep on pointing to that particular location after deletion of that object which it was pointing earlier. Now next topic is pointer pointing to a function, right? So how a pointer or how my pointer is passed to a function. This is the example of that. This is very easy if you pay attention for it. Let's suppose I'm having folio.h, right? Yes, Bhagat, I'll tell you at the end. Let me just finish it out because it is always it's about to finish. Let's take an example. Include folio.h, void function in pointer, right? Now, what does this mean? This is the declaration of my function whose argument will be of which type? Pointer type, right? That is why I'm using a pointer. Now, int main, int point p, a is equals to 5. So, I have taken a pointer and I have taken a variable. Now, p is pointing to whom? It is pointing to a, right? So, p is pointing to a. Function p. So, I've created a function p. Now, what is this function p? function P is, that means I'm calling a function, right? And that function is this function, which is created here, right? As soon as my compiler runs the statement, the control goes to the function. Now this function is taking argument as pointer q, right? Now anybody who can tell me pointer q is which argument, formal or actual? Yes, pointer q is formal argument. Actually, and p is what? Which argument? P is actual argument. The value of p is passed to q, right? Then I say point q is equals to 9. Now what does this mean? What does this mean? Anybody who can tell me? This is somewhat we have done in the previous slide. Yes, can I get your answers, please? Okay. Okay. So what was the value, pointer p value? It was 3. We know that pointer p value was 5. And 5 was passed to q. Pointer q was equals to p, right? So pointer q was pointing to address of p. If I write here pointer q is equals to 9, that means pointer q is replacing the value of 5, or indirectly let's take it as a trigonometric form. A is equals to 5. When I write p is equals to ampersand a, that means p is pointing to 5, right? When I pass this function to q, what happens? My pointer q is taking the value of p, right? And what is the value of p? Value of p is the address of a. So what is the address of a? It is, let's suppose 2402. So this pointer q, q is having the value, or p is assigned to q. So q is having value 2402, or in normal layman language, I can say q has started pointing to a. So what will be the value of q here? Q will be 5. But when I run the statement, pointer q is equals to 9. Pointer q is equals to 9. In this case, 5, a new value, 9 is assigned to 5. So it replaces 5 by 9. And when I print pointer q, it gives me value 9, right? And then if I print pointer p, it gives you what value? What is the value at pointer p? Yes, what will be the value of pointer p? 5. I 5. Because will it be 5 or 9? What do you think? It will be 5 or 9? Yes, it will be 9. Why? Because my q has replaced 5 by 9 and p is pointing to a. So a is now, instead of 5, it is 9. So the value will be, pointer of p will be 9. Good that you are clear about this topic. Right. Next is the relationship between pointers and arrays. So this is all we have done also. We have just done this also in the previous slides. Element B3, we can also access, if we write B3, it will give me the value at index weekly, right? And if I write like pointer p pointer plus 3, it will always also be giving the value at index weekly, right? If I write a bptr3, it will give me the address of v3. I think we have done all this in the previous slide, in this slide which we did this back. Let me tell you in which slide we have done all this. In this slide we did all. Like this is your address. This is your address of A. This is your value. This is your value of A. This is your address of 20. This is your address of 20. This is your value of 20 and this value 20. This is all which we were doing just now. The same one. So this is same as the one which I was taking you just now. Same. And this is the program way in how we can change the value. You can see into it later. This is a program to find out the mean of an array using a pointer. And see, I request you all that please try and practice the questions on pointer, because pointers help you a lot in performing multiple tasks like calling a function, passing a one particular value to a pointer. Instead of repeating the value, we just pass the address. So this is more easier task, and it is more less. It is directly less time taking for a compiler to execute a program with pointers. But if we do not use pointers, it will again be more time taking task for a compiler. So this is like a program. We are calculating the mean of an array using array name as a pointer. So what we are doing is, do you want me to tell you this program, or it's you can do it? Yes, should I tell you how it is working, or you can do it on your own? Okay, that's great. So we do have a character arrays. Now, what is a character array? Like char s hello, and if I write char pointer s equals to hello, it will be giving me the value of that pointer. It's same. So this allocates the string in modifiable memory and define s to be a pointer to the head of the string. So this is like what? It's an array which contains this value, right? But what I want to tell you is that we cannot write s equals to p. We cannot write s equals to p. Why? Because s is an array and p is a variable, right? And similarly, here I'm having char pointer s. It allocates a pointer, it allocates a string, right? S points to the beginning of the string, but the modification to the string, that is percentage x, is undefined. Like if I write here percentage s is equals to x, this is also not working. So in case of character array, array cannot be assigned to a value or a variable. This is wrong. So this is actually telling you what is the difference between char s and pointer s, right? Now, I like you all that you practice some of the programs based on this pointers. You can find out sum of squares and sum of cubes of an array elements using pointers. You can copy elements of one array to the another array using pointer to array to find the maximum value of out of the array elements. Right? We have done the searching operation on array. If if you remember, linear search and binary search. All the operations possible on array like multiplication of elements of array by 2, adding the all the elements of array by 5, incrementing all the arrays by 5, and all that. All the arithmetic operations which we can perform on array elements. Just like it's a practice session for you. You can practice all this and have a great knowledge about pointers in future. What I want to request you all that is that please have some practice sessions on all the topics which we have covered till now, right? And with this, my topic or my syllabus of C is ending. Now from tomorrow, we'll be beginning with our C++ sessions. Till now, what we have done in C is same as what we will be doing in C++ or what we can do in C++. So in C++, I am directly going to begin with the classes. I am not going to tell you what is an operator, what is a variable, what are decision statements, what are pointers, structures, and all that. Yes, Aniket, pointer is the last topic in your C. Tomorrow we'll be beginning with the C++. Yes, Bhagat, this is the last topic for C. You can check out the syllabus which you are having for the training. So till here, we have covered all the topics in C. And what my message to you is that all the topics which we have covered in C is also implemented in C++. Same. Only the printing and giving output and taking input statement is different. So that I'll tell you via program. But every other thing, the concept of structures and unions, same. Decision statements, same. Implementation of decision statements are same. Pointers are same. Arrays, declaration same. Everything is same. Right? So now from tomorrow, we'll be starting with the topic of C++. Right? Yeah, Suraj, we'll be doing file handling with C++. Right? And tomorrow we'll be starting with the C++. We'll be starting with the classes and objects, right? And all the concepts of inheritance and polymorphism, etc. will be covered in that classes and objects. Okay. Yes, Bhagat, I'll let you know. Let me tell you what is a dangling pointer. What is dangling pointer? Let's say I'm having a variable x that is 10, right? And I'm having a pointer, right? It's a pointer. I've created integer pointer. Int pointer, right? Now this pointer is pointing to which variable? It is pointing to. Right? So my pointer is pointing to. It is pointing to x. Right. Now let's suppose after some time, if I can represent this in terms of memory location, so we are having two variables here. One is ptr and the other is x. Okay. X is having value 10. Let's suppose it is stored at memory location 2402. Right. Now, if my pointer is pointing to x, so what it will store? It will store the address value that is 2402. Okay. Now let's suppose in future, after some time, after 2 days or 3 days, I deleted x. Right. So x is no more at this memory location. X is no more at this memory location. Now this memory location is empty. It is empty. Right. Now whenever I call ptr, whenever I print ptr, it will give me what value? It will give me 240. Or whenever I say pointer PTR, it will give me what value? It will give me 10. Why? Because since my X is deleted, X is no more, but still my pointer is pointing to that memory location. Now this is called as dangling pointer. Why it is called as dangling pointer? Because the purpose for which the pointer was created is now deleted in the memory. It is no more existing in the memory. But still it is pointing to that memory. So we call it as dangling. Right? This is what the concept is all about. Deleted object. My dangling pointer is to the object. Is it clear, Bhagat? Is it clear, Bhagat? Yes. Next is typecasting. Now, typecasting comes in the concept of when we are taking as void pointer as void. That means a pointer which does not having any data type. So let's suppose I say void pointer, and this is my value x, right? X10. Then I say void pointer is equals to ampersand x. So pointer is pointing to 10, right? Now, whenever I have to print this point, the value of the pointer, that means whenever I have to print PTR, what I assume it should give me value? It should give me value 10, right? Normally it happens, right? It should give me value 10. But since it is a void pointer, my compiler does not know what will be the data type of this pointer. So whenever I want that it should print me 10, how will I write? I'll write here int pointer. So if I'll be writing like this, if I like this, directly asterisk pointer, it will give me error. Why it will give me error? Because for the compiler, the data type of this pointer is void. Nothing. So what we need to do? We need to do implicit typecasting. We need to tell the compiler that yes, this pointer is pointing to a variable x, and the data type, the return value of this pointer will be integer. So in this case, my output will be 10. Did you understood now? So this is called as typecasting. Bhagat, understood? Okay. This happens in case of when we take it as void pointer. So any doubt to anybody in today's topic, in today's lecture? So with this, I end up my session for today. Tomorrow the class will be from 7 to 9 only, right? And soon you will be getting one quiz which you have to attempt it, and which will be evaluation parameter for your certification, right? And the marks for that quiz will be counted. So soon you'll be getting a quiz for that, and you have to give that quiz very seriously, right? Don't take it as a light parameter or light evaluation. So, and again, I'll be giving one more quiz for the pointer also, for the same topic on pointer. And tomorrow we'll be starting with the classes C++. So if you have any doubt in C concept or any topic of C, you can let me know. I'll be explaining you again. Right? So with this, I end up my today's session. Thank you for your cooperation. Good evening and good night.